Greetings. Well, my Amiga 500 rebuild project is beginning to take shape. It still doesn't look much, but I've made a few changes to make it more reliable and just generally better. First of all, I've attached it firmly to this old cupboard door just so that I can move it on and off the desk easier without breaking anything. Secondly, I've replaced these two capacitors up here. Now these are the original ones, and you can see they are a little on the crusty side and have started to leak. That's not just because they're old, partially it is, but it's also a symptom of possibly an underlying problem. And these two capacitors go across the two power rails of the video hybrid. This one here is on the 5-volt rail and this one on the 12-volt rail. Now these capacitors are 3300 microfarad 10-volt capacitors. And you can perhaps see a slight disparity there already. This one here, which is the crustier of the two, is on the 12-volt rail, and yet it's only a 10-volt capacitor. Now that may not have been a problem up till now, because the original power supply may not have given the full 12 volts. It might just have been more nearer 10 volts. But now that my new power system is providing exactly 12 volts, these just aren't really powerful enough now anymore. So I've replaced them with these ones, which are still 3300 microfarad, but they're 16 volt. So that now should last an awful lot longer. Another small change that I've made is I've added a little tiny switch down here. Now this wires directly into the JP2 and JP7A over here. That's better. JP7A over here. So that I can, at a moment's notice, just switch between having half a meg of chip RAM and half a meg of fast RAM, or 1 meg of chip RAM. I've not needed to switch between the two, but I was having a few issues with a few bits of software, and I was curious as to whether the balance between chip and fast RAM was an issue. So adding this switch just lets me flip between the two options really quickly and easily. One other small modification that I've made is I've replaced the battery on the A500, which was a rechargeable one, with a 3-volt CR2032 lithium cell. It's not just a case of just slapping this battery on. There's a slight modification to the circuit that you need to make, and I'll go through that separately a little bit later on. In bigger news, by now you'll all know that I've got a joystick at last. You'll have seen the rebuild of that joystick. Just a fun little video that I knocked together when it arrived in bits. But the biggest change is I have mouse now. I've cobbled together a little Arduino board connecting into the mouse port and connecting up to a PS2 mouse. Written a bit of software for it, which is on GitHub if you want it. I'll put a link to it in the description below. It's only about 15 lines of code. But I actually have a working mouse now. Oh yes, and I've added a second Gotek drive as well. I was fed up of having just one drive and having to switch floppies all the time on it, so now I've got two drives, DF0 and DF1. I have also been spending some time designing circuit boards to add to this. I've designed the power system board and sent that off to China to be made for me. I've designed the mouse adapter. That's also being produced at the moment. And I've also designed a simple ROM expansion card, which again is on its way to me. And as soon as those arrive, I shall get those built up and installed and tested and see if I can make this even better than it is already. Well, this is the little power board that I've designed. I've designed it specifically to fit where the current socket and the choke are to replace that whole section. It's designed to just fit flush on the top of the board. And the design of it is pretty straightforward. It's based around my trusty favourite TPS 82130 integrated switching 5-volt regulator. It's got everything you need to create a switching power supply all on one tiny little module. All you need to add is 2 resistors to set the voltage and a couple of capacitors, and it's got everything else all integral. It can power up to 3 amps. It's got a 0-volt dropout mode where if you put the same voltage in that you want out, it just bypasses itself. It's really a very clever little chip and so tiny, so easy to work with. The problem with building switching power supplies is it's a bit of a black art. You've got to lay it out just right to keep emissions low and all that sort of thing. Using these little modules, all that's done for you because it's all inside the chip. So it's a lot easier to lay it out. Coupled with that, I've got the TC7662. Now that's an interesting chip. The chip itself is not interesting, but there's an interesting story behind, well, I say interesting, behind why I've chosen this specific chip. And there's plenty of simple charge pump voltage inverters out there, but finding one which can provide enough current. I measured the current requirements using my simple multimeter and it came out at 29 milliamps. Now most charge pump chips are rated at up to 20 milliamps. This is the only one I've managed to find which can do more than that. This one's rated at 40 milliamps. However, it comes with a slight caveat. There's 2 versions of it. One of them is in a dip, 8-pin dip, and the other is in an SOIC, but it's in a 16-pin SOIC for some reason. It's an 8-pin chip in dip, but 16 in SOIC, and in SOIC, half the pins are just not connected. I mean, why? So the dip, counterintuitively, is actually a smaller chip. So for this design, I've actually had to resort to a dip chip of all things. However, I want this to fit flush on the board, so I can't use through-hole components. So I've come up with an innovative way to combat that. I'll show you a 3D model of it now so you can see just what I've done. Okay, here's the design in Blender, and here's what I've done to the chip. What I've done is, this isn't a socket that it's in. What I've done is I've taken the plastic shrouds from 0.1 inch pitch headers, flipped them over and inserted them pins through them so as to raise the whole chip up so that the pins of the chip are pretty much flush with the bottom of the board, which keeps it a through hole for ease of soldering, but allows it then to still fit flush. So we've got the 12-volt input, we've got the little switching regulator, that's all the whole regulator, that there. Just one tiny little board with an inductor on it. A couple of capacitors, 2 resistors, that's the 5-volt part of the circuit done. We've got the charge capacitor there and the pump capacitor, output capacitor for the minus 12 volts. And that all goes to a 4-pin header which lines up, or should line up, with the pins for the choke, which this replaces. The next board that I designed was the PS2 mouse interface. Now the current prototype I've used an Arduino for. I mean, nothing wrong with Arduino, but I want to simplify it and reduce the costs and things. So I'm a fan of PIC chips, so I've chosen a PIC 18 to make this with. It means I'll have to port all the software across, but it's not that complicated, it's not really a problem. It quite simply just 7 connections, sorry, to the D connector, 2 connections to the mini DIN connector, microcontroller in between, and a header for programming it. I've laid it all out on a board that's going to be external to the Amiga. So basically you plug this into the mouse port and then plug your PS2 into the back. Very simple layout. 9-pin D, microcontroller, PS2 port, nothing much to it. In 3D, that's what we're looking at. Mouse goes in the back, that goes into Amiga. Nothing much really to it. It's just a simple matter of programming, as we say. The Kickstart expansion board is also pretty simple and straightforward. It's basically splitting the data bus between 2 flash chips. There's nothing really particularly wonderful here. Address connections go to both chips. Data connections are split half and half between the 2 chips. Chip select and output enable just go to both chips. And that's it, basically. It was a fun one to root. I had a little go at some Manhattan routing in the middle here. If you're not familiar with Manhattan routing, it's where you have one side of the board has all the traces going horizontally, and the other side of the board has all the traces going vertically, just like the roads are laid out in Manhattan. In 3D, that's basically what you get. This plugs into your existing Kickstart, and you've got your 2 flash chips. The 2 together make the 16-bit expansion. Now, once I'd created this and sent it off to be made, I suddenly had a bright brainwave, and there's a modification I really want to use for this. This is aimed at using 39FS020A flash chips, which is the right size for storing 2.04 or 3.1, but it's perfectly capable of taking 39FS040 chips, which are twice the size. And I could do one tiny modification, which is to take the A18 pin, which is, I think, this one here, on both chips, which is currently, no, it'll be the top one here actually, I think, which is currently not connected to anything, just floating because it's not connected on the 020 chips. And give that a pull-up resistor to 5 volts and a switch down to ground. Then I could put an 040 chip, and the switch will basically give you half the chip in each position of the switch. So I could take both 2.04 and 3.1 Kickstart images, concatenate them together into one large image, and burn that onto a pair of 040 chips, and then I've got a switch that'll just let me flip between the 2 images. And you don't need twice as many chips. So that's a modification that I can quite easily do with a few bodge wires and things, which I think I will probably do. And then I might potentially do a slight redesign of the board. But it depends if this board works first, of course. It should do. I've prototyped this up. I'll show you my prototype in a moment, actually. It's quite comical. And I've had it working. Took a little bit of finagling with the prototype, but it worked eventually. So yes, I've created those 3 boards. I've sent them off, and I'm just waiting for Mr. Postman to drop them through the door. I promised I'd show you the modification to the A501 for the battery. It's a very, very simple and straightforward modification. Basically, it's take off the existing rechargeable battery and solder in its place a holder for the CR2032. That's the easy part. The next part is, because this is not rechargeable, it has to be isolated from the rest of the circuitry. Otherwise, it's going to try and recharge it, and that's not going to make this battery happy. Unfortunately, the charging circuit for the existing battery consists of one resistor. It's so simplistic. And that resistor is the bottom one in this bank of 3. But you notice on here, it isn't a resistor anymore. You take that resistor off, it's R913, it's labelled under here, you can't quite see it now. But R913, you remove that resistor and replace it with a diode. Anode this side, cathode this side, which basically allows then the current to flow from the battery through the diode to the real-time clock, but not the other way from the power supply. Can't get through the diode to the battery. And that's basically it. I do have another problem with this A501 in that it never quite knows what the time is. I mean, it works, kind of, but if you leave it for a few days, you'll find it's lost time. So I'm thinking that I've tried adjusting the trimmer here and it's had no effect. So I'm thinking that possibly the crystal needs replacing. So that's going to be a job for me to do at some point. Get myself a new crystal and pop that in. But that's not particularly important right now.